Just kidding, folks. Welcome to the Daily Space Weather. It's a rare afternoon edition, and I'm in rare form today. So let's get through today's Daily Space Weather video. We've got anomalies to show you. But first, imagery of the sun. That was 304 angstroms. Here's the colorized magnetogram, also from the SDO. We've got two sunspots. 2822 up here, 2823 down here, both of which have degraded over the past 24 hours. Likelihood of solar flares has dropped a little bit. There is still some likelihood of coronal mass ejections. Here is the 193 angstroms full disk view. Ionized iron. Coronal holes rotating and associated with the south solar polar field region. Over here and over here. More about coronal holes later in the video. Next, here is just sunspot 2823. It's been pretty stable over the past 24 hours, degrading a little bit. Here's 2822, a little bit more coherent, and a larger set of umbrae. Here's what's going on in the solar system as the planets chase the sun across the sky. There's where things will be in a week. And the sun's at least chasing the planets across the sky from my perspective. Right now, the sun and Mercury and Mars and Venus and the moon are all up there at the same time. So there's Mars, there's Mercury, that's Venus and the moon, by the way, even though I couldn't click on it. The 10.7 centimeter radio flux at 75 solar flux units. Here's a one-year chart of that, and I would note this blue line down here, the AP, the post-dam AP index, the planetary magnetic field, has jumped up quite a lot here over the past just couple of days here. At the same time, the coronal mass ejection struck, actually. So the AP index suddenly rose up. We'll talk about that in a later video, as we don't want today's to be too long, since it took us more than one take. And let's go over seismicity over the past, well, this is actually, what is that? It's a multi-month chart. It's the past 90 days. And you can see there's an earthquake lull going on here. No magnitude 7 earthquakes since March 20th. And earthquake lulls typically end in earthquakes. VolcanoDiscovery.com's got great resources on earthquakes. You can go back a couple of years there. And I like this global seismic activity chart. You can also sort by magnitudes. You can even go back to the past year, past 30 days, and so on. So there are the 5+ magnitudes, and there is the only one 6 magnitude quake in the past 24 hours. And there's one from Panama. All right, let's go up the list here. We saw some deep quakes such as this 4.3 at the Fiji Islands. That's over 550 kilometers depth. So no 7 magnitude earthquakes, folks. Earth is due for a 7 magnitude earthquake. Perhaps we're seeing some foreshocks now associated with those. If you've got forecasts for earthquakes where you would expect the next large earthquake to be, let us know in the comments. Tell your friends and foes on YouTube about it. Perhaps you'll save somebody's you-know-what. Who knows? Also, we saw a couple 5 magnitude quakes there at depth at the Kuriles Islands and at Wallis and Futuna. And volcanoes have been erupting as well, including Subanose-jima. It's producing a 6,000-foot ash plume. Bulusan. Bulusan. I've never heard of it. It's located on Luzon Island in the Philippines. Is now on the list. Featuring elevated fluid movements of gas, water, and possibly magma under the surface. New eruptions could occur at any time, most likely in the form of sudden phreatic stream-driven or phreatomagnetic water-magma interaction-driven explosions from the summit crater or flank vents. Please don't attempt to build a campsite on the lower slopes of Bulusan. Sinabung also erupting, flight level 080. It's an 8,000-foot ash plume there. Semeru also erupting. exploding indeed. 14,000 foot ash plume there. Dacono, flight level 070 at 7,000 foot ash plume. Along right up on Kilauea, which continues to expand. Also some activity at the vents. And apparently Volcano Discovery has a weekly live video about Kilauea's eruption. Links to that on the site as well at volcanodiscovery.com. The Great Sitkin volcano of the Aleutian Islands has elevated its aviation color code to yellow. So a little uptick there at Great Sitkin. Sabancaya exploding, 11,000 foot ash plume. Fuego in Guatemala, same country as Sabancaya, by the way, also exploding. Sporadic emissions of ash there. Revenador exploding, flight level 150 in Ecuador. The Peruvian volcano Sabancaya exploding, producing a 26,000 foot plume of ash, and sporadic emissions from Nevados de Chilean, and a lava flow on the north flank, which remains active. Please do not attempt to pole vault the caldera. This public service message brought to you from SMASH staff and I at Massive Personal Risk and Expense at smashomash.com. Let's get back to the sun-facing suite of instruments on the Suite GOES 16. No major solar flares over the past 24 hours. There was a C-class flare midway through the day yesterday. That was at about 9:30 Universal Time yesterday. Since then, only some B-class enhancements of the X-ray output. Now that we've talked solar flares, let's talk coronal mass ejections. None have struck, at least at the levels of the GOES 16. And you can see this has remained flat despite seeing a coronal mass ejection strike yesterday and a geomagnetic storm associated with it. One thing we did see is some very strong magnetism kickoff and some very sudden changes in the magnetism, which is what sparked that KP7. It wasn't just the coronal mass ejection, folks. It was also magnetism. Or were they the same? Leave us a comment. Let us know if you have a theory. It's unsettled science. But in any case, that's the 3-day chart from the GOES magnetometer. Here are the polarities of the current sheet, the heliospheric current sheet, that is. Earth is in a South Pole-oriented current sheet. And if you're wondering where the data comes from, thanks for tuning in. You must be a new viewer. It comes from 51 ground-based magnetometers, as well as magnetometers on stereo A at Lagrange point 5 and stereo B at Lagrange point 4. Here's a line of sight ecliptic plane field plot, a three-dimensional simulation of the same data. And the blue line tells you where the B field would be located. And here's another set of imagery here from the National Sunspot Observatory. The line of sight coronal hole plot. It shows you the sun's B field in blue. And you can see some coronal holes there in the southern polar region. And by the way, folks, like I said, a little more about coronal holes here. Coronal holes are low pressure zones. How low? Well, they're so low that the sun blasts protons all the way to Earth out of those coronal holes. It's true, folks. Solar protons are coming out of those coronal holes. So this area right here is emitting a solar wind stream. We call it a coronal hole wind stream. And we can expect to see that in about 3.5 days. We can see that sunspot 2822 remains a beta delta gamma class, although it has been shrinking. There still is some likelihood of significant solar flares. Sunspot 2823 will be renamed alpha class later today, I think. And by the way, sunspots are like high pressure zones. Yes. Sunspots are like high pressure zones, and coronal holes are like low pressure zones. Anyway, let's get back to geomagnetism. You can see this KP7 geomagnetic storm having taken place yesterday when that coronal mass ejection struck. And we forecasted the coronal mass ejection. It's part of the reason why we have a channel. I haven't seen anybody else doing so, and it's because I don't think anybody is able to do so. In any case, we've been forecasting coronal mass ejections. If you weren't aware, cheers. Here's the real-time solar wind. And we see a very diffuse solar wind here down below 3 protons per cubic centimeter at only about 2.25 protons per cubic centimeter. Solar wind speed, did I say speed? Solar wind density, only 2.14 protons per cubic centimeter. Solar wind speed, 436 kilometers per second. we are expecting a coronal hole wind stream ahead of the one we showed earlier. Anyway, here's the magnetohydrodynamic pressure. You're looking at the space weather modeling framework of the pressure in the geospace surrounding planet Earth. And we have this homogeneous pressure zone here. And we've seen this ever since the coronal mass ejection subsided. We see a very homogeneous pressure, both in the bow shock region to your left and the magnetotail region to your right. Here are ground magnetic perturbations, and we'll show you some ionospheric anomalies later in the video. For those of you who saw this morning's video, thanks patrons, you saw some electron anomalies, and we're seeing some magnetic anomalies happening here. So you're seeing these pulses coming out of the middle of the planet right here. We're going to let that play through a second time here as we're seeing some oddities in the realm of magnetic perturbations. So you see, though, usually the magnetic changes to planet Earth's B field come out of the poles, and we see some just kind of pulsing out of the equator region here. And we've noted some significant anomalies before in this. It hasn't turned into a full global-wide event there. It just kind of came out of the Indian Ocean and then stopped being perturbed. So when we say geospace delta B, folks, we're looking at changes to the Earth's B field. We showed you the sun's earlier. Of course, Earth's is shaped a little bit differently. Also keep in mind we're looking at nanotesla, the magnetic flux density here, as opposed to magnetohydrodynamic pressure, a different unit, nanotesla. Geospace delta B, changes to Earth's B field during this polar excursion. By the way, we do regularly stream live to Twitch. This video will be a YouTube exclusive. If you want to watch our live streams on Twitch, twitch.tv/smAsho. Thanks to our new and old subscribers over on YouTube. If you're watching there, well, you must be watching there because this is a YouTube exclusive, but we also make videos on BitChute. Perhaps you've seen our hydroxychloroquine video, which we released on March 19th of last year. And why would we do such a thing? Because it was a plausible cure to the coronavirus. It got demonetized on YouTube. We've also seen the writing on the wall for years, so we created our own website. Welcome to the Neo Renaissance. Check out our own web pages, smashomash.org, smashomash.com, and the rest of the web ring therein. Today's featured product is available at the smAsho merch link right on our homepage. It is the My Vaccination Status is None of Your Business t-shirt, or whatever. It comes in a whole bunch of different products, 41 of them. T-shirts, sweatshirts, tank tops, hoodies, phone cases, art prints, canvas prints, postcards, stickers, comforters, duvet covers, masks, socks. Let's get to today's cosmology segment. It's a good one. It'll be integrated in the daily space weather video and not separated today, as we've been overworked and underpaid. Today's cosmology segment starting out about diamond anvils. If you're wondering what a diamond anvil is, it's literally an anvil made out of diamonds, where we take two diamonds and we press them together. We put a tiny groove in between those diamonds, and then we fire a laser through that tiny groove where it meets a collector, and we examine the properties of the materials that are at millions of pounds of pressure in that little tiny groove in that diamond anvil. How do I know? Because this is how we've created things like super-ionic water, liquid metallic hydrogen, and other superionized materials undoubtedly in the laboratory. What's the title of the article? It's in phys.org's Earth section. There may be up to 70 times more hydrogen in Earth's core than in the oceans. Why is it that when the Soviets dug down 18 kilometers, they didn't find heavy elements down there? Why did they find so much hydrogen down there? Does this rewrite all of geology? Does this rewrite all of planetary formation, concordance model, cosmology? Well, some of us believe that it does. Some of us also believe that superionized materials are not only the frontier of material science, but that superionized materials are the explanation behind things like the magnetospheres of planets, and indeed the intrinsic properties of things like stars, the more massive, large celestial objects floating around. And here's a little graphic about what the hydrogen silicon situation looks like in the diamond anvil. The high pressure experiments, they represent the frontier of a lot of different science, and indeed apparently part of it appears to be cosmology, as some folks are finally starting to realize that perhaps stars and planets are made of superionized materials. So when we talk about superionized water, some folks are coming around to think parts of certain planets like, I believe, Neptune and Uranus now. People are starting to believe it's made of superionic water. And superionic water is interesting, to say the least, as when we compress water down to millions of atmospheres, we get this. Yeah, this little masterpiece right here, which is a cubical lattice structure, where the oxygen nucleons are these red dots. Those are the oxygen nucleons. And you also get the metallic hydrogen separating from the water. So the water forms into oxygen and hydrogen in their own separate lattice structures. The liquid metallic hydrogen just sloshes around inside of the oxygen nucleon cubical lattice structure. It turns black. It behaves like a superconducting magnet. It's quite interesting, to say the least. Did you think that when things get very, very compressed under millions of atmospheres of pressure, that they just rip apart into plasma? Well, turns out that's not what happens at all. They turn into superionized materials. Go have a read about superionic water if you haven't yet done so. Let's pick a random number. And in the realm of cosmology, this random number coincides with 696, which is an object over at the Neil Gorell Swift-Bat X-ray Observatory. 696 turns out to be the Great Annihilator, a low-mass X-ray binary / BHC, a black hole something or other. And let's take a look at this. The Great Annihilator is an interesting object, and we'll cover this in greater depth in a later cosmology segment. It's also known as the catchy name of 1E 1740.7-2942. Here are the X-ray outputs of the Great Annihilator. And it's a particle emitter. I'll just leave it at that. And let's see if we can see a visual of this. I don't think this is going to show up on really anything here. Let's see what it shows up on. And you can see an empty spot here on the 2 mass. No real surprise there. Let's take a look at it on Pan-STARRS. And you can see a nice empty space there as well. Does it show up on the Finkbeiner, which is hydrogen alpha? Is there a bunch of hydrogen gas? Not really. And we're zooming way, way out. Does it show up on X-ray? And there it is on the Chandra, the Great Annihilator. Today's featured, quote, random, end quote, cosmology object, which coincides with 696 at the Neil Gorell's Swift-Bat X-ray Observatory. It stands for Burst Alert Telescope. The Great Annihilator. Today's astronomy picture of the day is the 2 edge-on galaxies, one of which looks like a field hockey stick, and Comet Atlas. Yes, Comet Atlas 2020 R4. Yes. Today's astronomy photo of the day, astronomy picture of the day. You can find it yourself at apod.nasa.gov. Continuing on with the heliosphere. Yes, another paper coming out about Voyager. It's very important, as Voyager 1 and Voyager 2 have left the solar system. Yes. Now, we don't really know what's going on outside the solar system, although it's probably pretty likely that we're seeing some galactic cosmic rays out there. But what's the environment really like? Well, we're getting data for the past 8 years, since 2013, when Voyager 1 left the, we'll say, the termination shock. The real question is, what do we have outside the heliosphere? Do we have multiple shells that are at perhaps varying distances? Do we have completely different environments within the shells? Or is it something else entirely? The answer is we don't know. However, Voyager 1 and Voyager 2 are sending back data, and for that, we thank them. So this is an interesting article here. You'll find this all over the Science Wire about Voyager 1's plasma hum. And without getting really in-depth into this, you can find links to the paper as well on Nature Astronomy. And shout out to Eugene. Thanks for exposing my mental handicap and finding the paper for me. Cheers. I needed a laugh today. So here is this is a visualization, a GIF animation here of the signals that were detected. And this, I like this article because it has this animation. You can find this one on scitechdaily.com, another article about the same article. The eerie sounds of interstellar space and its density measurements. And again, folks, we don't really know what the nature of the heliosphere is. So, I'm going to bring up this image here. We really don't know what the shape of this is. Some people think that this is going to be a crescent shape, like this. Some people think it's roughly spherical, but ultimately, we only know what's going on out here toward the solar apex. So the direction that the sun is moving is toward the solar apex, and that's around where Voyager 1 and Voyager 2 left the heliosphere. The real question is what's going on back here, and back here, and here, and what about at the solar poles, which are, who knows? Who knows what the orientation of the solar poles are? If you want to learn more about astrography, check out plasmascape.com. Plasmascape.com will direct you to this visualization, and this is one of the best visualization tools that I'm aware of. And just to give you a quick crash course on this, this is what you'll see when you first default to Plasmascape. If you press the A button, that will bring up these different tabs. And the one we're talking about here is the solar apex. That is the direction that the sun is moving. So if you rotate this around, you'll see that one of these tabs is the solar apex. That is the direction that the sun is moving with respect to the interstellar chimney. So while the entire interstellar chimney is moving toward Deneb, the solar apex is moving within the interstellar chimney toward the solar apex. So if we zoom all the way out to number 5, and then zoom out even farther, you will see this hourglass-shaped structure. That hourglass-shaped structure is the local chimney. That's what contains hundreds of local stars, and that's the direction that the sun is moving. So to orient this in the solar apex's direction like this, and the chimney is actually moving about toward this region right here. So this is Deneb right here. That's where Deneb's located. So the chimney's moving in that direction, but the sun is moving in this direction with respect to the interstellar cloud, the interstellar chimney, as some folks call it. And this is likely got to do with solar mechanisms, we'll just say. So check out Plasmascape if you want to visualize that stuff. And check out this article. It's linked, as well as the sounds you can hear here on scitechdaily.com. Great article there. And there it is on Nature Astronomy. And that's today's cosmology segment. Looking at things like electron flux, we see some disorderly Van Allen belts around planet Earth right now. Let's get to it. Here's a diagram of what they normally look like during non-geomagnetic storm conditions. And while we aren't in geomagnetic storm conditions, we do see anomalies going on. So here's a one-year chart of the electron flux as reported by Solon.info. Here's a 3-day chart. And we're seeing fairly nominal levels here. Nothing too exciting to comment on there. And here's the electron flux forecast model here. NOAA forecasting a small uptick in the electron flux. I would tend to agree. And here's the total electron content forecast. And we showed some anomalies earlier this morning. Thanks again, patrons. We showed some electron anomalies here south of Africa, around this region. Those seem to have now subsided with this rotation of planet Earth. Although we do see some nighttime charge-up belts. So, not particularly disorderly right now, though. Anyway, that's the total air column, all the way from a GPS satellite to your handset, potentially. And here's the ionosphere, and the ionosphere is looking quite anomalous right now. We see a very large, low-frequency region here, and what you're looking at is vibrational frequency in millions of vibrations per second. So we're seeing some odd charges here. These areas right here. Some space there as northern hemisphere summer approaches. And we're just seeing some anomalous charge ups and charge downs in the ionosphere there. We'll let this play through, and then we'll bring up the latest image. Ionosphere looking wobbly to me. What do you think? Leave us a comment. Let us know what you think. Anyway, there's the latest image coming in at 1815 Universal Time. Here's a diagram of the atmosphere. We just show this daily to show where the ionosphere is. It's right there, around 300 kilometers, the F ionosphere layer. Next, thanks to our patrons. Our patrons aren't effed, no matter how effed the ionosphere is. Patreon.com/smAsho. If you'd like all kinds of early reports and alerts and graphics and multimedia and updates about solar activity and so on, consider becoming a patron at patreon.com/smAsho. Thanks again, patrons. Here's today's meteorology segment, starting out with surface winds on the western world. So there are those. Some calm and stormy wind ridges in the North Atlantic, as you can see. Some windy areas right next to some calm areas. Here are the jet streams of the western world. A fairly concentrated jet stream right over the east coast of the U.S. right now. Here are the jets of the eastern world. We've rotated it far enough to see New Zealand, and shout out to our viewers from Munda. Thanks for tuning in from Munda. And here are the surface winds of the eastern world. Some 180-degree bends down there near Antarctica. Next, looking at lightningmaps.org. I use it when I hear thunder. Powered by blitzachtung.org. Lightningmaps.org. Convince your friends and foes that you're Thor by forecasting thunder. And we've got some French lightning. Yowzers. Some concentrated lightning bolts there, striking France. Did you know that when you're in France, you pull down your pants? Did you know that? Next, the lightning mapper on the NASA GOES. I like it. Some lightning in the Gulf of Mexico. Having a strong morning of lightning in southern Mexico. And next, looking at pressure cells. Here are pressure cells on windy.com. Most of the U.S. encased in high pressure right now. Pretty clear skies over most of the U.S. Here is where we expect things to be according to the Euro forecast at 12 noon Eastern Daylight Time tomorrow. Next, the U.S. Doppler radar map. And we're actually going to show you the visible radar. I mean, the visible satellite for once. So we've got some showers over central PA and Florida and Montana and North-South Dakota. But most of the country seeing pretty clear weather today. Here's a visible satellite for once. And we see some rapid cloud nucleation happening over places like Pennsylvania, West Virginia, Kentucky, Tennessee. Nice. And here's the water vapor map, and we're actually going to zoom in on Indiana here. So since we see some rapid cloud nucleation, we're going to zoom in right on the Indiana-Illinois border. Right there. And we'll show you some weather pornography for once. And here's some fantastic imagery of clouds rapidly forming, folks. It all has to do with things like pressure gradients and Hall currents and evaporation and heat transfer and winds coming off of the Great Lakes and lots of other factors. Here's the water vapor for the same region. It may look very deceptive to you to look at the visible versus the water vapor. And we love using the visible satellite. We should make more afternoon videos because of it. Again, there's the water vapor, and there is the visible. Great footage there. And once again, here's the U.S. Doppler radar map in case you missed it. And let's do bonus features. We'll show you the latest imagery from El Teide, Spain. Actually, we may have a different one here. 6 hours and 14 minutes. Okay, this is the newest one. 5 hours and 54 minutes. We're going to Big Bear this time to show you the latest hydrogen alpha imagery from the National Sunspot Observatory Big Bear location. Still lots of filaments on the sun. There still is a possibility for coronal mass ejection. In fact, let's check on it real quick before we close out the video with some more solar imagery. And indeed, we see a coronal mass ejection while we made the video. So it's on the far side of the sun, folks. You can see this kicking off here on the opposite side of the sun. This is the view from stereo A, which is located at Lagrange point 5. Earth would be off in this direction from the perspective of stereo A. No Earth-facing coronal mass ejection, just a far side one. Let's show the final bonus features. So here's the colorized magnetogram in high res. Here's a close-up of sunspot 2823. It's alpha class now. Here's sunspot 2822. Still beta class, still does harbor the ability to produce some C-class solar flares perhaps. Here's the intensity gram of 2823. And there's 2822. It looks like it's going to degrade to an alpha class as well if it continues on the same route. Again, there's the colorized magnetogram of that. Here's some more imagery to close things out in 171 angstroms. A full disk imagery and then some close-ups of the most active regions. Sunspot 2823 and sunspot 2822. Thanks for tuning in to our rare edition, the rare late afternoon edition of the Daily Space Weather. You won't see it happen very often, and you won't see me screw up the morning video very often. Cheers. And may that solar wind be at your back.